up. Let g of x be this fourth degree binomial, and we're going to find the derivative at 1, and we're going to use it to write an equation of the tangent line to the graph of g at the point 1, negative 1. Okay, so last time we did, we figured out the definition of the derivative at a point, and the first one was a bit weird, and it was this one right here. And then there was the other definition where it seemed like a little easier. So these two are the definition of the derivative at a point. Sometimes if we're gonna use the definition of the derivative at a point, sometimes the algebra involved is harder to get the answer doing it one way than doing it the other way. And so which one should we try and do, the first one or the second one, to find the derivative? Okay, first of all, we know that we want to find the tangent line, the equation of tangent line to the graph of g at this point 1, negative 1. So what was that point slope form? Point slope form said something like y minus y1 equals mx minus x1. And so we need to find three things. Well, three things that we got to plug in there. What do I plug in after x? What should I put in after x? What should I plug in here? Minus 1. And then what should I put here after y? Minus a negative 1. Okay. So can I already put plus 1, I guess? And we're trying to find the slope at that point, no? The slope. And that's what we're going to use, where a is what? A is 1 here, no? So we want to know at a equal to 1. This is 8. Looks like it's an 8. All right, at a equal to 1. So let's use the second definition, because I already know that the second one, I think, is that the one I'm going to use? Let's go. Let's use the second definition. So f prime at what? F prime at 1 is going to equal to? Oh, I forgot that lim as x approaches what? Using the second definition, as x approaches what? 1, as lim as x approaches 1. And we got what? F of x? What is f of x? Well, we don't have f of x. We have what? What do we have? G of x? Yes? So maybe even here I should just erase this and put g. Yep. We'll look at that. G prime at 1. And so what is g of x? What's g of x? What should I substitute in for g of x? What should I substitute in for g of x? What is g of x equal to? It's telling you g of x is equal to what? G of x is that thing right there. That's what g of x is. So take out g of x and plug in what? X to the fourth minus 2. And we're going to now subtract g of a, which is g of what? G of 1. Yes? Can we do that in our heads quickly? What's g of 1? If we plug in 1 here, see what I'm saying here? X is 1, g of 1. And that'll be 1 to the fourth is 1 to the fourth is 1. 1 minus 2 is negative 1. Yes? We're actually working it out. And this is negative 1, no? Over what? X minus what? A is 1, no? Yes. So then we got g prime at 1 is going to equal to the limit as x approaches 1 of x to the fourth. Well, isn't that a minus a negative? Will be a plus 1. So what's negative 2 plus 1? That'll be what? Negative 1? Yes? Yes? And at the bottom is x minus 1. G prime of 1 is going to equal to the limit as x approaches 1 of, isn't that a difference of squares, everybody? Yes or no? Couldn't I write down, let me just kind of tell you what this is. Wouldn't it be the x squared squared? Isn't that the same as x to the fourth? Yes or no? Say yes, yes it is. And minus 1, that's a difference of squares, no? Which turned out to be what? What is the answer to that with a difference of squares? X squared plus 1, x squared minus 1, yes. Well, this is going to be x squared plus 1 and then x squared minus 1. But then can't we do some more there, no? So this is going to be what? X squared plus 1. And then what's the difference of squares here, no? It'll be what? X plus 1, x minus 1. So that's completely factored out. So that turns factored out would be this. So let me put that over here. X squared plus 1. X plus 1, x minus 1. Over x minus 1. What can we do now? Let me erase this because I need space. What can we do now? Cancel out x minus 1 and x minus 1, yes? Cancel out? And now I can plug it in, yes or no? Yes? If I plug it in, that would be what? One would be 1 and then 1, it would be 4, no? Yes? 4? Which then that's the rate of change of the function at 1 is 4, and we are done. Now, let's do this. What I'm going to do, look, just to make you really understand what we're saying here, is that let me multiply it out and graph this and graph this. And you'll see that it's a tangent line at point at an x equal to 1. This will be 4x minus 4 equals y plus 1. Get the y by itself. You don't have to do this. I'm just doing it. Y equals 4x minus 5. So I'm going to graph. Go ahead and write this one down right there. Y equals 4x minus 5. And then you're going to tell me x to the fourth minus 2. I'm going to go ahead and graph it. All right? Let me go ahead and graph it. Let me go to decimals. Let me get out. Save annotations? No. Decimals? Decimals. All right. So equation 1 was what? Y equals what? What was equation 1? Was y equals what? X to the fourth? X to the fourth minus what?
5.
Minus 5? Minus 5? And the other equation was, the one that we came up with is what? Y equals what? The one I came up at the very end.
Oh.
Come on. What was the other? Y equals x to the fourth. What's the original equation?
It's 2. Minus 2.
Minus 2? How do I delete this? Okay. And the other equation is y equals what?
4x minus
Wow. Would you look at this? Would you look at... Come on. The tangent line at x equal to 1 right there. Yes or no? Yes? Got it? Everybody? Let's get out. And because we are still recording? It's still recording. No, don't get out. Let's go. Let's continue. Continue. Lesson 2.2, defining the derivative of a function and using derivative notation. So in general, not just at a given point, but in general, the general equation of the derivative is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. But the limit has to exist. So in general, that's what the derivative is right there. Not at a point A, but in general at any x value. Let's go ahead and do one problem dealing with finding the derivative for this cubic function here. So we're going to let f of x equal that, and we're going to find the derivative of this function, the general derivative of it. And we're going to use this this definition of the derivative here. Here we go. The problem will always be, and sometimes it's for me too, no, that algebra is the problem, not calculus. Here we go. Let's do the f prime of x. F prime of x is equal to the limit as h approaches 0. Okay. Here we go. Should we go step by step? Let's do this step by step. Look. What we're doing here is we're plugging in for x. What are we plugging in for x? What are we plugging in for x? We're plugging in x plus h. So wherever you see an x, you're going to plug in x plus h for this first part. So I already see here there's an x. So for that x, I'm going to plug in x plus h. So this is going to be x plus h to the third power. Minus, here's another x. And x is x plus h. Minus. For x, I'm going to plug in x plus h. Yes. And then I'm going to do what? What does it say to do here? Minus what? What am I going to do? I'm going to go do what? I'm going to minus what? F of x, yes? And what is f of x? What is f of x? X cubed minus x, yes. Minus, in parentheses, put x cubed minus x, yes. Over what? Over what? H. The problem is algebra, not calculus. So let's go to this part. The cubic of this is really what? What is it? X plus h multiplied times itself 3 times? Let me do this on the side here. What this is saying is, what is x plus h times x plus h times x plus h? That's really what's asking there. Well, we got to work it out. Let's go. Let's do it. X times x, x squared. X times h is xh. H times x is axh. Yeah, xh. H times h is h squared. And then we got to still multiply times x plus h. I'm going to put that in the front here, x plus h, because it makes it easier to distribute. And then I'm going to multiply it by this, x squared plus x plus h plus x plus x plus h is 2x plus 2xh plus h squared. And then we're going to multiply this out. X times x squared is x to the third. X times 2xh is 2x squared h. X times h squared is xh squared. H times x squared is hx squared. I can put it underneath this one. Hx, erase. X, let me see. OH times x squared. Yes. Let me put x squared and then put h after. Then I'm going to multiply this times this. That's going to be 2xh squared. Yes, that goes with this. 2xh squared. Then we're going to do h times h squared is h cubed. I'm going to go ahead and put this answer and simplify it back over here. So it's going to be f prime of x is going to equal to the limit as h approaches 0 of this whole thing. So I'm going to replace that x plus h to the third by this that I came up with. So this is going to be x cubed. 2x squared h plus 1x squared h is 3x squared h. And then here, 1x h squared plus 2x h squared is going to be plus 3x h squared. And then I have plus h cubed. I'm going to simplify this one some more. This is going to be negative 1 times x is negative x. Negative 1 times h is negative h. I'm also going to distribute this one. And then that's going to be negative x cubed. Minus times a negative is a positive x over h. Now we're going to simplify some things here from the top. So f prime of x is going to equal to limit as x approaches 0. There's nothing that cancels out with x to the third. Leave it alone. 3x squared h. Yes, actually there is. Haha. Undo. Do you see what cancels? You guys see the x cubed and negative x cubed cancel? Yes? Cancel. What else cancels? Doesn't the negative x and the positive x cancel? Cancel. That is it. Nothing else. So this is going to be what? 3x squared h plus 3xh squared minus h to the third over h. Can we factor out an h from the top? Somebody say yes. Extra credit, somebody's. Can we all factor out an h from the top? Factor it out?
H cubed is supposed to be positive. And then
Where?
minus h out.
Where? What? Where? Oh, plus?
And then minus h out.
Who? This one?
Yeah.
Where did that mess up? Negative x?
See the blue x minus h? You need to write the.
Come up and show me because I can't see it.
You're supposed to write this.
Oh, did I forget writing it down too? Oh yeah, over here?
Yeah.
All right, thank you. All right. Can I factor out an h? Yes. Now I can factor out an h? Yes. Factor out an h. And so what's left inside? What's going to be left inside? It's going to be 3x squared and then 3xh plus h squared minus 1 over h. All right. What can we do now? Cancel the h, no? And can I now plug in 0? Let's plug in 0. So if I plug in 0, can somebody else tell me again why did I change from h to x here? So h goes closer to 0, not x. H gets closer to 0. So now that h gets closer to 0, I'm going to plug it in for h here. So then 3x squared is left alone. H becomes 0, so 0 times this is 0. H is 0, so this goes away, and this is going to be minus 1. That is the answer. That is the derivative. So, what's the moral of the story here, aside that there's so much algebra involved that I even predicted that I was going to make some mistakes? Yes or no? It's a lot, all right? And we're only doing this for this week because there's an easy way to do it. So you're like, is this what calculus is? Well, this is what calculus is based off until I give you the tricks, because there's tricks to this. But this is what it's all about. All right. What are the other notations of for the derivative? Here, that's what the derivative is. Go ahead and write this down. Let's go. If we use the traditional notation y is equal to f of x to signify it's a function, then to indicate that y is a function of x, or that the independent variable is x and the dependent variable is y, we can denote the derivative in several ways. This calculus was invented about 500 years ago by two people, by Isaac Newton, who was he? He's English. And then there was Leibniz from Germany, and they came up with them independently with this idea of calculus. And so there's different notations to the idea. This is the most widely used. This is called f prime of x. And f prime of x is the same as saying y prime. It's the same as saying dy dx. Dy dx was invented by Leibniz. df dx. Now these are getting out of hand over here. We usually just stick to these definitions here, or these notations. df dx, rarely do you see that. I'm just giving you all these other ones from the book, but they really are rarely used. These are the notations that are mostly used. So for the one derivative we just did, f of x is x cubed minus x. In that previous problem, the derivative can be denoted as f prime of x equals what was the derivative? What was the answer I came up with, or we came up with, I came up with your help because I was making mistakes? What was it? Wasn't it 3x squared minus 1? I know it's that because I already know the trick. I did this quickly in my head already. That's the trick. And then it could be denoted as what? Y prime equals y prime. This is y. Y prime equals 3x squared minus 1. And also the other one is that dy dx. dy dx is 3x squared minus 1. They all signify the same thing. I guess df dx, you can write that down if you want to. Go ahead. All those, I rarely do we see those. The first three are the ones. Good? We're good to go, everybody? We're ready to go? Let's. You can go to the website and get it later on because I got it. We got to go because it's a short day. Let's go, number 2. Let's go to number 2. Write that down. We're going to give you 20, what time? 29. We got about 20 minutes to get this done. Problem number 2. W is the amount of water measured in gallons in a bathtub. T is the number of minutes since it was unplugged to drain out the water for the function W of T. What is the meaning of W of 10 equals 13 and W prime of 7 equals negative 4.3 in the context of the problem? Write complete sentences. So, the big idea here of calculus is that W prime of something is a rate. This right here is a rate. It's a rate of change. And when we're saying W of T, it's just kind of like a measurement of something, like when we say function of t, like say for example, f of t equals negative 16t squared. This right here, without the prime, could be measuring height or length or height, some kind of just not a rate. Whereas if I go f prime of t equals, let's say I'm doing the derivative here. Then this is a rate. F prime of t is how fast is something moving or falling. So this is a rate. The derivative is a rate. So you got to understand the difference between these. So when we're doing here, up here it says, what is the meaning of weight W of 10 equals 13? Anybody, what do you think that means? What does this mean? It's okay to say, what do you think? Vivian, what is it? Everybody say the number of minutes it was unplugged to drain. So wouldn't it be the amount of water? This is time, no? This is time. So time, and then this is water. So in what? In gallons? So gallons. So at time equal to 10 minutes. Is this minutes? At time equal to 10 minutes after it was unplugged, there were 13 gallons of water in the bathtub. Let's see. 10 minutes after after it was unplugged, there was 13 gallons of water in the bathtub. In the other one, it says, on the 7th minute, the water is draining at a rate of 4.3 gallons per minute, where the key word for this is a rate for the second part. That makes sense or no? So, I mean, I'm not very good at writing, and some of you guys are better at writing. This could have been better said that 10 minutes after it was unplugged, the bathtub was unplugged, there was 13 gallons of water in the bathtub. And then it says on the 7th minute, after the bathtub was unplugged, water was draining at a rate of 4.3 gallons per minute. Okay, I gotta get going. Okay, so you guys want to get this from the website, go ahead. And last problem for today, let's go, number 3. Last problem. An equation of the tangent line to the graph of y equals f of x at the point where x equals 2 is that. Find f of 2 and find f prime of 2. See, this is the idea behind everything of this question. What does the tangent line to a curve tell you about the rate of change of the curve at that point? You got some curve. And at this point, say this point, you got this tangent line at this point. What does this tangent line tell you about what's happening at this point for the curve? It's telling you what? The rate of change of the curve at that point. That's what the tangent line tells you. Okay, so anybody, what's f of 2? F of 2 is 3, correct? All you gotta do is just plug it in. If this is true at that point, at the point 2, this would be, you could just do f of 2 equals 4 times 2 is minus 5 is be 3. Yes. And what is f prime of 2? Come on. What's f prime of 2? I'm just looking at you. What's f prime of 2? What's f prime of 2? Anybody? What is the slope of the line? What's the slope of the line? What is the slope? What is this? Slope. So the slope of the line is the slope of the rate of change of the curve at 2. So the rate of change of the curve, we just get the rate of change of the curve to be 4. It is 4. So the tangent line to f of x at x equal to 2 is y equals 4x minus 5. Therefore, they share the same y value at that point of tangency. So that's we already went over that. They also share the same rate of change. At that point of tangency, the slopes are shared. So f prime of 2 is 4. All right, we're done.